of the particle is 15 meters. At the instant the x-coordinate of the particle is 15 meters. The question is, what is the speed of the particle? What extra information they are giving? What extra information?
You want to find out the speed.
No, I want to find the speed. Good. I want to find the speed, which is a scalar. What else? At what instant? When, what is 15 meters? X is 15 meters. X, 15 meters. At the instant when X is 15 meters, I want to find the velocity. Okay, not the velocity, the speed. But the speed is the magnitude, instantaneous speed, and magnitude of the velocity, instantaneous speed, not the average, but the instantaneous is the same than the speed. Magnitude of the velocity in 2 dimensions, and the speed instantaneous is the same thing. So in order to find the magnitude of the velocity, what do I need to find? Yeah, but I don't have I can integrate the acceleration, it's true, but will be, if we know that the acceleration is constant, what is better, to use calculus, integration, or just simple to remember that there are 3 famous equations for constant acceleration, which already are derived. I use the big 3, rather than using calculus. You can use it, but it will be more difficult. No, you basically you will derive the equations, and then I mean, if they are here already, the physics community derive the equation for you, and I provide to you. All right. So I have this situation. I want to find V, magnitude. How do you find the magnitude? What do you need to find the magnitude of the vector?
So this is the third.
I mean, I am not talking about this magnitude of the vector. Yes, how do you find the magnitude of a genetic vector?
Square root, squaring it, and squaring each component.
Okay, square each component and find the square root.
Yeah.
So since we are looking for the magnitude of V, we need to get, before getting this, you need to get what is Vx and what is Vy. Correct? And once we get Vx and Vy, at this moment, I can find the speed. But if I don't have Vx and Vy, I cannot find it in 2 dimensions. So what I need to find? Vx and Vy, and then find the speed. In order to find Vx, I go to one of the equations. And I will say, okay, they are asking for Vx, which I can use this equation, the motion at constant acceleration. Now let's start working the equation independently, which is easier. So since the acceleration is constant along x and constant along y, I can use the equation along x and along y independently. Separately. So because I have information about x, maybe I can start from that. Because I want to find Vx and Vy, I have 3 equations. There is one more, which is Vx squared. This is in 1 dimension. Equal Vxo squared plus 2ax x minus xo. These are the 3. Since we have this x, we have V initial, and we have x, what is the best equation to work with? The last one. The last one, the one that is independent of time. This is if you want to go straight forward. Another way will be to find the time at that position. And then I can work with the first one. Right? Either way, whichever way you want. I can find the time with this equation. Once I get the time, I can go to the first equation along x and the first equation along y and find it. What is Vx and Vy? And then I can find the speed. Any question on that? All right, so because I have V and position, let's see. V Vxo squared plus 2a x minus xo. I am looking for Vx. This is Vxo. The object start moving how? How the object started moving?
It's at 0.
In the positive y direction, how much is then the Vx component at the origin, at the beginning?
9.
At the beginning,
0.
0. Along x is 0. Plus, is there any acceleration along x?
Yes.
How much?
2.
I don't have to work with the IJK notation because I'm working separately, independently, x and y. Okay, what else?
And delta x is 15.
15. Good. So Vx squared will be 4 times 15. How much is that? 60. And what will be the Vx squared? The square root of what? I mean 60. So how much is Vx? Anyway, I have to square, right? Okay, but anyway, I want to find that. I have to square later. How much is Vx? The square root of 60.
7.75.
Let me put the square root of 60 meters per second. Let's go down, we have Vx. Can we find Vy? Similarly, how much will be Vy? Vy squared, what will be? How much is Vyo squared?
Oh, it's 81.
81, which is 9 squared. Vy, we know that Vy is this one, Vyo. Plus, how much is the acceleration along y? -4. Times 2, right? So, times 2. So, will be 2 times -4 times how much is y final?
Yeah. Well, we know it's 0. But we can't know that.
We don't know. So, for this reason, we need to find the time. Because if we know the time, then we can find what will be y at that moment. We don't have the time. So, since we don't have this y, and we have yo, which is 0, so in this equation, what we need to find now? Y. How can we find y? I mean, if we don't know y, but we don't know the time, but we have this equation. So from this equation, maybe we can find the time, right? Let's see. So, let's go to x equation. Let's see, 15, 0, how much is Vxo? Vxo,
So it's 0.
0, plus 1/2 times, how much is Ax?
2.
Times t squared. Can we find t? So this cancels out, and what will be t? The square root of 15. Good. Second, at that position is t is this. Now can we find y? How much will be y? The position y at that moment. Now, since we have the time, we don't have to use this equation.
Use another one.
We can use the other one, right?
Right.
We can go to this equation. What is the equation for y? The first one, correct? So what will be the first one?
So we get
Vy equal to what? How much is Vyo?
it's 9.
How much is the acceleration?
-4.
-4 times what?
Square root of 15.
The square root of 15. Good. So how much is that? 9 minus 4 times the square root of 15.
We got about -6.
-6 meters per second. This is Vy. How much is Vx? The square root of 60.
That is 7.75.
7.75 meters per second. what will be then v, the speed? So if I ask for the velocity, what will be the velocity? How do you write the velocity? Look at what is velocity in 2 dimensions, not speed. If I ask for the velocity, what will be the velocity? What is the formula for velocity? In 2 dimensions, what did I say that is formula for velocity? Look, there is the theory. What is the formula for velocity? This is velocity. This is velocity. Right? How can I write the velocity in 2 dimensions? 7.75 I, and this is the difference between velocity and speed. This has I minus 6j. This is my velocity. So if I ask my velocity, you can write the velocity like this in IJK notation. You can write the velocity like this. 7.75 negative 6 by rectangular components, or you can write the velocity by magnitude and direction. How do you find magnitude and direction of a vector when you have the components? The magnitude. The square root of this square plus this square, which was what they asked. That's the speed. Find it. The square root of 6 squared plus 7.75 squared. 9.57, 9.6 meters per second. And how much is the direction? Tangent negative 1 of?
Negative 6 over
Of
7.
negative 6 divided by the square root, by 7.75. How much will be that? Second tangent?
Negative 37.75.
Negative 37 degrees. Okay, good. I did this question for a reason. So you have other two questions to practice motion in 2 dimensions here. Now, can you see that only a single question, how many steps you have? You imagine how difficult. So this is just to let you know, if I put this question in a test, it's a multiple choice, but it's not a single question. It's not a simple question. It's a question that if you miss one, and remember you have like a 15 question or 12 questions.
Do we have to show all our work on the test?
No, but how can you guess? There is no way. I mean, you don't have to show me. I don't care multiple choice about the work, but you can see that one of these multiple choice, I only give like from 12 to 15 multiple choice. So and I let you to miss. So if I give 12, I let you to miss 3. To get 50% of the test grade, 50-50. 50 is the multiple choice, 50 the free response. So it's very easy to make mistakes because there are multiple steps. So if you are not sharp, if you don't do the study guide several times to understand, it's not just do it and that's it, several times and get the practice and understand the concept, you easily will make mistakes. So I am letting you know because this is the study guide I use for the test. And not all questions are like this. This is a very difficult question. But for this reason, I leave the option, I give the opportunity to miss 3 or 4 questions. You can make mistakes if you don't know or your knowledge is like this, but 3 questions, you cannot miss 8. If you miss 8, you didn't understand the topic. Okay? And this is 50 points. But anyway, the questions are like this, for the most part, many questions, for the reason you will have only 12 and 2 free responses. 12 multiple choice, 2 free response. That will be the structure of the test. And I usually give like a 3 questions to miss, 2 questions, depends on the how difficult is the test. All right. Any question here? Now, what are the questions that I can ask in motion in 2 dimensions? Find the velocity, find the speed, find the position along y, find the time, find the speed, find the velocity vector, find the direction. So look at how many questions I can make out of this question. So I could ask, I gave this information and they asked for the speed only. But if it was a free response, I will ask, find the time, A. B. Find the velocity along X, the velocity along Y,